So we're going to take a quick break from our basic tools of geometry and vocabulary, and we're going to talk a little bit about logic. So logic is very useful in the real world. It's the right way to think through information. It's a good way to process through information. And we usually do that with what we call conditional statements. So a conditional statement begins as a conjecture, just an idea, a thought. It's an opinion based on incomplete information. So you can see down below that, all dogs are black. A quadrilateral has 4 congruent sides. The sum of 2 congruent angles is an obtuse angle. Those are all conjectures. They're all statements, and in most cases, they could be opinions based on incomplete information. So we're going to take these and compare them, and we're going to put them into what's called conditional statements. Conditional statements are in the form of what we call if-then. They're called if-then statements. So these are conditionals. So you got to start keeping up. There's a lot of C vocabulary words, and so we want to make sure that we keep up with what all the C's mean. We have conjectures. Those are just opinions. They're statements. Conditionals are written in if-then form. We can write that if P, then Q, or even shorter than that, we can say P, then Q. You would read that if P, then Q. So the hypothesis is the P, okay? That's the part that comes after the if. The conclusion is the part that we use for Q. It follows the then. So if the hypothesis, then the conclusion. And then one last C vocabulary word, on this one anyway, for now, we'll have more, is a counterexample. It proves the statement false. So it can be an example, it can be numbers, it can be a problem, it can be a picture, it can be words, anything that proves that whatever the statement says is false. So let's look at this. It says, write each conjecture as a conditional, then show the conjecture is false by providing a counterexample. Again, there's all our C words. So write each conjecture. We have conjectures, they're statements, as a conditional, an if-then. Okay, so we need an if-then to show that, and then we want to use and then we want to provide a counterexample to prove it's false. So all dogs are black. We can say if the animal's a dog, then it is black. We try to avoid starting with if in the hypothesis, or if it is a dog. Okay, you could say if it's a dog, but we try to be a little more clear with our words, and this can vary. It doesn't have to be exactly the way that I say it, but if the animal's a dog, then it's black. Well, give me a counterexample. A counterexample, you can be thinking of one right now. I could say my counterexample is my dogs have 3 colors. That's a good counterexample. You may have your own counterexample. My dog's white, my dog's red, my dog is black, my dog is brown, whatever. Okay, it's just something that proves that somebody is stating this as a fact. Dogs are black. And you say, well, no, they're not. And then, well, prove it to me. Well, mine, so you can use any example. It doesn't matter what it is. So the next statement, a quadrilateral has 4 congruent sides. Well, that's not true. A square is a quadrilateral and a rhombus is a quadrilateral, but all quadrilaterals don't have 4 congruent sides. Give me an example. Okay, you could do a rectangle. You could draw a picture. You could draw a picture of a parallelogram. That's a quadrilateral that has 4 sides that aren't congruent. You could use words like a trapezoid. Okay, so anything that shows that quadrilaterals don't have to have 4 congruent sides, just 4 sides. Okay, the last one, the sum of 2 acute angles is an obtuse angle. We're saying, oh, and I didn't write that as an if-then, but we could say if you sum 2 acute angles, then the sum will be obtuse, or you could say something like that. I don't like how these are words. They're not working out very well, but you could say, if you add two acute angles, the sum will be an obtuse angle. That's what you could say. If you add two acute angles, then the sum will be an obtuse angle. Okay, and so you're saying that if you have two acute angles, so pick any two acute angles, and you might say 60 and 70, and then is an obtuse angle. But then that's true. It was 130, and that's true. It's obtuse. But what if you said 20 and 30? Those are acute angles. Well, that adds to 50, which is not obtuse. And so you might say, okay, well, here's an example. 20 plus 30 is 50, and that's not obtuse. So that might be how you give me a counterexample. Okay, so a conditional converts it to an if-then statement. If it is a quadrilateral, then it has four congruent sides. So we're saying it is a quadrilateral, but then we're saying because it's a quadrilateral, it has four congruent sides, and that part's not true. Okay, my conclusion is the part that isn't true. So we always want to, our hypothesis is the true part. Our conclusion is the part that may or may not be true, based on what the hypothesis was. So now we had our conditional. We would shortcut, we can use P then Q. Now we have what's called a converse. Converses take the order that you wrote the statement in and you switch them. Okay, so we're going to switch the order. So instead of if P then Q, we're going to say if Q then P. So you literally pick up the hypothesis and the conclusion and you switch them. Now you may have to wordsmith it a little bit to make it make sense, but you want to switch the order. You're going to change the order by writing the hypothesis and the conclusion. Okay, so you're going to change the order by switching the order of the hypothesis and the conclusion. Okay, so we would say then, let's look at this statement. We have this conditional. If it is raining, so this is my conditional. Okay, this is my hypothesis. Then I am wet. That is my conclusion. Okay, so I'm saying, the original statement says if it is raining, so P is the raining part, then I am wet. Okay, so let's decide, is that true or false? If it is raining, okay, we're going to say it is raining. Am I going to get wet? I am guaranteed to get wet. It's raining outside. Am I going to get wet? False. When might that be false? Well, you could be under an umbrella. You could have an umbrella. Just because it's raining outside doesn't mean that I'm going to get wet, because I could be inside. Okay, there's any number of reasons. You might have on a raincoat. But it is raining. That's the part that cannot change. Okay, but we're saying that it's raining, and that means I have to get wet. So that's kind of how you want to read it. And that's not true. So let's switch the order of that and then determine if it's true. It says if I am wet. So we're going to say, remember, we're going to say then if Q, then P. If I am wet, then it is raining. So you're saying that the only way you can get wet is that it's raining outside. That's what that's saying. If I'm wet, if you ever see me and I am wet, dripping with water, then it has to be raining outside. Well, that's also false. How else can you get wet? You can be in a water balloon fight. You can be in a sprinkler, okay? So you could have a water balloon fight, and that might be your counter example. Okay, maybe you get wet in the shower, right? Maybe you sprayed your hair with a water bottle. I don't know, whatever it is. I'm saying that if I'm wet, that the only way that I got wet was because it's raining outside. And so the I am wet is a statement. It is raining is the question. Does that mean that it's raining? So that's how you could read it. It is raining. Am I wet? So you can say that second part as a question if it helps you to figure out whether it's true or false. Let's try this next one. If it is a holiday, then it is Thanksgiving. That's my conditional, my if P, then Q. If it's a holiday, it is a holiday. Is it Thanksgiving? Well, not necessarily, right? So that could be false. Give me a counterexample. Well, it could be Christmas. It could be Easter. It could be July 4th. It could be Kwanzaa. It could be whatever other holiday there is. Labor Day. Memorial Day, okay? So let's say July 4th. It could be Labor Day. That one's coming up, okay? The converse of that, remember, converse is if Q, then P, okay? Converse. So if it is Thanksgiving, I could write, if it is Thanksgiving, then it is a holiday. So I'm saying it's Thanksgiving. Is it a holiday? Yes, that is true. So there's no counterexample. There's only a counterexample when you're trying to prove something wrong. So don't give me a counterexample if it's true. You're only giving counterexamples to prove things wrong. Now, we have a statement called a biconditional. A biconditional can only be written when a conditional statement and its converse. So the original statement, the original P then Q, and then the original Q then P. If they're both true, then you can write what's called a biconditional. We can combine them. Okay, and what we would do is we would say, we would use the words if and only if. It would say P if and only if Q. Now for short, you can say IFF. That stands for if and only if. Okay, that means it's a definition. Once we can say it forwards and backwards and it's true both directions, then that is a valid definition. If a polygon is a triangle, then the polygon has 3 sides. Is that true? It's a polygon, so we're saying it's a triangle. Does it have 3 sides? Yes, it's true. Okay, so there's no counterexample. Let's write the converse of that. Flip them around, right? Q then P. If the polygon has 3 sides, then it is a triangle. Okay, so then let's read that statement and decide whether it's true or false. Let's read it as like a statement so that we can answer it. It has 3 sides. The polygon has 3 sides. Is it a triangle? Yes, so that is also true. So notice that we have 2 truth values. If they are both true, then you can write a biconditional. Okay, so here's what you do. You go back to your original statement. Here's my original statement. We'll say the polygon is a triangle. That's the hypothesis. The polygon is a triangle. I'm going to shorten him. If and only if it has 3 sides. You don't have to write the words exactly as long as you get the idea. If and only if. The polygon is a triangle if and only if it has 3 sides. So let's look at the next one. If 2 angles are complementary, that's my hypothesis, then the sum of the angles is 90. That's my Q. So let's look at our words. If 2 angles are complementary, then the sum of the angles is 90. That's true. That's the definition of complementary. True. Okay. There's no counterexample because there's no way to prove that wrong because that is true. I'm saying 2 angles are complementary. Is the sum 90? Yes. Okay. The converse. If the sum of the angles is 90 degrees, then the 2 angles are complementary. Okay, so the sum of the angles is 90. Are they complementary? Yes. So again, those are also both true. Okay, So if they're complementary, then they add to 90. If they add to 90, they're complementary. And we know that that is our definition. So we can go back, and this means we can write a biconditional. So we go back to our original statement, and we'll say two angles are complementary. And then I'm going to write it shorthand, if and only if, just to show you you can, if and only if, read that. Don't read IFF. Read if and only if the sum of the angles is 90. Okay, two angles are complementary if and only if the sum of the angles is 90. So we have our statement, if P then Q, right? That's our original statement, if P then Q. That's our conditional. Then we have our converse, okay? We have our conditional, then we have our converse. Our converse is if Q then P. A conjecture is just a statement, an opinion, and then a counter example, our other C, is proof that it's wrong. Okay, so it's a reason through an example or a problem or a picture that proves that a statement is false.